This is Dr. S. Mohan Lakshmi, Professor and Head, Department of ECE from Rohini College of Engineering and Technology. And in this video lecture, we are going to see what is electromagnetic model, units and its constants. So first we'll see the overview. So of course we know electromagnetics is the study of both electric and magnetic phenomena which is caused by electric charges either at rest or in motion. So at rest we call it as statics. And in motion it is actually the wave propagation and everything. The existence of electric charges was discovered more than 2.5 millenniums ago by Greek astronomer and philosopher Thales of Miletus. He noted that straw and small bits of paper attracted to an amber rod after being rubbed with silk or wool. So the Greek word for amber is electron, from which was derived the words electrons, electronics, electricity and so on. So from elementary physics, two charges, of course we know two charges, it is positive and negative, which forms the sources of an electric field. So moving charges produce a current which gives rise to a magnetic field. A field is a spatial distribution of a quantity which may or may not be a function of time. A time-varying electric field is accompanied by a magnetic field and vice versa. In other words, we can say that time-varying electric and magnetic fields are coupled, resulting in an electromagnetic field. Under certain conditions, a time-dependent electromagnetic fields produce waves that radiate from the source. So, electromagnetic model. So coming to this model, there are two approaches in the development of scientific subject. So either it will be an inductive or deductive. Inductive approach, which is nothing but where one follow the historical development of the subject, starting with observations of some simple experiments and inferring from them laws and theorems. It is a process of reasoning from particular phenomena to general principles. Whereas the deductive approach, which postulates a few fundamental relations from an idealist model or for a particular model. The postulated relations are axioms from which particular laws and theorems can be derived. The validity of the models and the axioms is verified by their ability to predict consequences that check with experimental observations. So coming to the various field quantities which is used in the electromagnetics. So obviously we know that we are going to see in the further chapters the electrostatic as well as the magnetostatic, as well as we are going to see about the time varying. So coming to the electric field or electrostatic, whatever it is. So the field quantity what we are going to mostly concentrate is with the electric field intensity and electric flux density, where it is denoted by the symbol E and D respectively, as well as it is measured in volt per meter and coulomb per meter square respectively. And coming to the magnetostatic field or magnetic field, so we are going to deal with the two parameters, which is magnetic flux density, which is identified by B and it is measured in Tesla. And similarly, the magnetic field intensity, which is denoted with the letter H, which is actually measured in ampere per meter. So where all these quantities are vector quantities, E, D, B and H are all vector quantities. And these are the basic units, SI units, and these are the constants. Of course, we know velocity of light in free space, which is represented by a symbol C, which is 3 into 10 power 8 meter per second. Similarly, we deal with the two more parameters, which is mu naught and E naught, which represents permeability of free space and permittivity of free space. So which is measured in 4.2, where the value was 4 pi into 10 power minus 7 Henry per meter. And similarly, this permittivity, that is epsilon naught, is measured with 1 by 36 pi into 10 power minus 9 farad per meter. So what is electromagnetic radiation? So interrelated electric and magnetic fields traveling through such space are called as electromagnetic radiation. So this travels with the speed of light in vacuum to the cosmic speed limit. So the real number is, of course, it is given clear, but we approximate it to 3 into 10 power 8 meter per second. So these are some of the examples of the electromagnetic radiation. There is AM and FM radio waves, which includes TV signals, cell phone communication, there is mobile communication links, microwaves, infrared radiation, light, x-rays, gamma rays. All these belongs to, or these are the examples of the electromagnetic radiation. Thank you.